This is our community garden at our summer residence. We grow tomatoes, beans, and herbs, and they grace our table most of the season. The soil's very clayey, so Sarah and Kathleen decided to put everything in raised beds so it could drain and not just be a mud hole after a big storm or regular watering. Sarah was away for a week, and she left me with a garden and something she'd printed from the internet on how much water vegetables need. Big mistake. I mean, after almost 50 years now, she should know better than to give me such an opportunity. I was in charge of the picking and watering, so I got curious about how much water these things were really getting. Second big mistake. Here's the problem. The paper Sarah left me talked about how many inches of water from rain or a sprinkler vegetables needed per week. I think the number was like an inch a week. At first I wanted to know how much water I was putting down when I followed the instructions left for me. I watched this rain gauge for several waterings, but I didn't get consistent results. One time I got like 1/4 of an inch, and another time I got 2.5 inches. What was going on? I put out 6 plastic cups around the garden and measured the depth of water in each after I'd run the sprinkler for the allotted time. You can see the problem better here in this simulation of the sprinkler. There are 3 water collection cups placed out on the ground, and you can see that there's a distance, there's an opening, and no water space between the streams. The cup on the right is hardly getting any. The cup in the middle is getting a little bit, just because it's partly within the stream, and the cup on the left is getting a fair amount. I finally solved the problem with a large collection plate, which you can see on the ground there. And if you look carefully, you can see it's beginning to accumulate some water. The reason that the small rain gauge works, however, for regular rainfall can be seen in this simulation. Take a look. The rain is falling in no particular preferred pattern. It's just falling randomly all over the place. So a commercial rain gauge is fine for rain, but don't try to use it to gauge how much water is falling on your garden, whether you're using a sprinkler. It would be nice to have an expression that would allow us to calculate how many minutes we should leave the water running in order to get a certain part of an inch or multiple inches of rain on the garden. So what we want is how many minutes per inch. What do we know? We know the square footage of the garden. What can we find out? Well, we can measure how many gallons come out of the sprinkler in 1 minute. So what we need to do to make this expression is to start with what we've got, which is the square feet, and end up with minutes per inch. There's your square feet. And we need to multiply that by a unit conversion factor. Here's what I mean. First of all, we would like to take a quantity and multiply it by something that will allow us to actually change the units. So, for instance, we want to convert 3 inches to centimeters. Well, a measurement is always a count and what it is you're counting. In this case, we're counting inches, and there are 3 of them. We want to convert that to a different count that would allow us to count in centimeters. Let's take 1 inch, and what is it equal to in centimeters? Well, the international community has all agreed that 1 inch is exactly equal to 2.54 centimeters. This is an equality. This is truth. The part on the left is equal to the part on the right. That is 1 inch. An inch, 1 time, is exactly equal to a centimeter, 2.54 times. We now need to convert this to something that's equivalent to 1. Let's divide, in this case, both sides by 1 inch. It should be obvious that we can now cancel the inches because they're actual factors in the expression. We can also cancel the ones, can't we? And what are we left with? We're left with 1. The same thing divided by the same thing is always equal to 1. There's no cancellation we can do on the right. That has to stay the way it is. But what we have now is 1 is equal to 2.54 centimeters divided by 1 inch. Let's use that. Let's take the 3 inches and multiply it by 1. Except the 1 we're going to use is this special one that we just created. 3 inches multiplied by 2.54 centimeters over 1 inch is going to allow us to cancel out the inches and leave the centimeters. That's going to give us 3 times 2.54 times centimeters, which is exactly what we've been looking for, and we've got to bring the centimeters down because that's the unit of measurement that we need. Here's where we were before. Here's where we started out. On the left side, we've got square feet, but on the right side, we've got minutes per inch. We need to start multiplying by these unit conversion factors to bring in the units we need and get rid of the ones we don't want anymore. We want to get rid of the square feet. A logical choice here would be to multiply by a unit factor, which is however many square inches there are per square foot. We've only multiplied by 1. The number of square inches in a square foot, they're equal to each other, so that should give us 1. We've now gotten inches in there. There's our inches. Now we need to deal with gallons, the amount of water we've got. A gallon of water is a certain number of cubic inches, actually, which we can look up. It's going to be a problem with that. We'll see what it is later. We need to get the minutes in there. How many minutes does it take to put out a gallon of water for our watering system? We cancel the square feet. We've canceled the gallons. We're canceled the square inches, and we're left with 1 inch unit on the bottom, not inches cubed anymore. Now what have we got left? We've got minutes, and we've got inches. That gives us the unit we were looking for. Let's start putting in the numbers that actually relate to our garden. First of all, we have 660 square feet. I measured the garden, and I calculated the square footage. It's obvious that 144 square inches is equal to 1 square foot, 12 times 12. Again, we're still multiplying by 1 here. 1 gallon of water we can look up. That's 231 cubic inches. I filled up a 5-gallon container with water from the running water system, from the running sprinkler system. For a bit of comic relief, here's how I measured the water flow rate from the sprinkler. I took a 5-gallon bucket into the garden, put the sprinkler down in it while it was set up the way I would usually water with it, and I measured the amount of time it took to fill 5 gallons. And I found out it took 2 minutes to give me 5 gallons. Let's start canceling. Square feet, cancel square feet. Square inches cancels 2 of the cubic inches. Gallons cancel gallons. And we're left with 165 minutes per inch. Notice that all we really did was take all the numeric coefficients out here and do the arithmetic on them. That's what you can do in your calculator. You don't have a gallons button on your calculator. You don't have a cubic inch button on your calculator. All you can really do is arithmetic. But there's our specification for this particular garden. Now we're ready to test it. The great Richard Feynman, the great physicist, once said that if you have a theory, it doesn't matter how beautiful it is, it doesn't matter who you are, if it doesn't agree with experiment, it's wrong. Let's go. We've already made an educated guess that 165 minutes per inch will predict the amount of water that we'll get. Now we just have to decide how to carry out that test. Our method will be to calculate the water for 60 minutes using the expression. We're then going to run the water for 60 minutes and measure how much water collects in the garden. And then we're going to compare the prediction with the results. What we're saying is 60 minutes will give us how many inches? That ratio should equal 164 minutes for 1 inch of water. Let's do a little algebra on it to clean things up, make it more manageable. And then all we have to do is solve this for the unknown amount, the number of inches of water that we'll get for 60 minutes. We come up with, canceling the units, and 0.37 inches of water we should get for 60 minutes of watering. That's a little difficult to measure with a standard inch ruler, so let's convert it to millimeters. A good unit conversion factor to convert inches to millimeters is 25.4 millimeters per inch, again, equal to 1. Canceling the units out, we get 9 millimeters. That's the amount of water we should get after 60 minutes of watering. I used a large pie plate to get a better, more accurate measurement. So let's check the depth. And there it is, folks, just a little bit less than 10 millimeters. What have we done here? We thought about what we wanted to calculate. In this case, we wanted to know how long to leave the watering system running to get a desired depth of water on the garden. We then put something down as a starting unit, a value we could measure. We then tried to get the final units we wanted into the expression by repeatedly multiplying by 1 using unit conversions. We then canceled all the units we could to verify that we were left with the desired answer units. Back to the original expression. Then we put in all the coefficients for our garden. Some we could look up, some we had to measure for our particular situation. And finally, the Feynman test. We conducted an experiment to see whether our prediction agreed with reality. If you don't know who Richard Feynman was, you're missing out on the 8th wonder of the universe. Look him up. I'll put a link down in the material below. Of course, you have to take rainfall into account, but that should be obvious. Happy gardening!